Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over base strength and the base ionization constant, KB. So let's talk about strong bases and weak bases. So in a previous video I talked about strong acids and weak acids. It's exactly the same. So a strong base, just like a strong acid, we said strong acid was an acid that will completely ionize in water, 100%. So that way you don't end up with the acid anymore. You just have the H plus ion and the negative anion in solution. Same thing for a strong base. Strong bases are going to completely dissociate in solution. So that means that if I have a strong base like NaOH or sodium hydroxide, if I have 1 molar of that NaOH, then when I put it in water and it dissolves, that means that in solution, I don't have NaOH together. I have just separated sodium ions and hydroxide ions. They are separated from each other, floating around in solution. They're not together. So if I have 1 molar solution of NaOH, that means I have a 1 molar solution of Na plus and 1 molar solution of OH minus. Okay, so what are the strong bases? The strong bases are your group 1 or your group 2 metal hydroxides. The group 1 metal hydroxides, like sodium hydroxide, lithium hydroxide, are highly soluble. But your 2A metal hydroxides, your group 2 metal hydroxides are only slightly soluble. This is good for things like antacids. So if you have your antacid tablet, there's a lot of the metal hydroxide. 2A metal hydroxide is going to be the active ingredient in there. Um, so one thing to note about your group 2 metal hydroxides is that for your group 2 metal hydroxides, like magnesium hydroxide, you have 2 hydroxides that are in the formula. So for this magnesium hydroxide, when it dissolves in water, it's going to completely dissociate into magnesium 2 plus ions, and then you're going to get 2 moles of your hydroxide ion. So this is a 1 to 2 ratio here. So 1 mole of this is going to give us 2 moles of that. So that's something to keep in mind if you're ever dealing with a group 2 metal hydroxide. And the other thing to note, compared to your strong acids, right? So when you had your acids, they will ionize in 2 steps. So here we have our sulfuric acid. So you'll have sulfuric acid. This 1 proton will come off first. So the first one will come off and will be transferred to water. You get the hydronium ion plus what's left over is HSO4 minus. And then the HSO4 minus will then release a second proton to water, forming another hydronium ion, and then you get the sulfate ion left over. So this will happen in 2 steps. Whereas in your strong bases that have 2 hydroxide ions on them, that's going to just dissociate in 1 complete step. So these 2 are going to come off, and you're going to get 2 OH minuses. So no 2 steps needed. Okay. What about weak bases? So weak bases, the most common weak bases produce OH minus by accepting a proton from water. So they don't have anything in them that's going to give off like an OH. So they're going to take a proton from water, and that produces the OH. So for example, here's our generic equation for a weak base, or just for a base in general. So we have B for base. The base here is going to react with water. It's going to take a hydrogen from water and forms this BH plus complex aqueous. And then what's left over is the hydroxide ion. So here's an example of ammonia. So ammonia, NH3, is going to take a hydrogen from water. It's going to form your ammonium ion, NH4 plus. and then you've got your OH minus left over. So this is a typical weak base. Almost all of the weak bases that we have are going to be nitrogen containing compounds. So they're either ammonia or they're some amine, which is like having an ammonia molecule with one of its hydrogens replaced by some carbon group, right? So for example, you'll have ammonia. So ammonia has this formula here. So this is ammonia. You'll notice that there's two lone pairs there. And amine would be like if you replaced one of the hydrogens with some other group, like a carbon group. So we can have a methylamine. So if we do a methylamine, we could have hydrogen, hydrogen, and then here you'd have a CH3 group, a methyl group. So it's called methylamine. So both of these would be weak bases. So you'll notice that here the nitrogen has a lone pair, and so that makes it a good weak base because that lone pair will attract the hydrogen from water. So what happens is that you have water. Oops. So water here has the hydrogen. This hydrogen here, or maybe that hydrogen there, is going to be attracted to the negative lone pair. And so that negative lone pair is going to want to take the hydrogen from the water, and then that's going to form your NH4, right? So this is going to be, then you got that plus charge, and then you've got the OH minus left over. So you've got the OH minus left over. So this is typically what's happening. So again, because of this lone pair here, this would act as a base, and so this lone pair would be attracted to the water molecule, the hydrogen. So the hydrogen would be attracted to the lone pair, and so it would attach there, leaving the OH minus behind. So typically your weak bases are going to be some nitrogen containing substance for the most part. So last thing I want to talk about is Kb. So I talked about Kb a little bit in an earlier video, but here this is just like Ka. So if you remember that Ka was the ionization constant, or the acid ionization constant for an acid, to measure the strength of that acid. So Kb is the base ionization constant. And this is going to measure the strength of your base. And so just like any equilibrium constant, just like Ka, Kw, those sorts of constants, this equilibrium constant is set up exactly the same way as we would set up any equilibrium constant. So the ratio of the products, the concentration of the products on the top, in this case, our generic concentration. So we have our pH plus, which is your conjugate acid of the base, is the concentration of that conjugate acid on top plus the concentration of your OH minus on top divided by the concentration of the base on the bottom. So this is your expression for your Kb. And of course, I mentioned your P values, right? So we have a pKa, which is again the negative log of the Ka value. You also have your pKb. So you just take, to get your pKb, you take the negative log of your Kb. And your pKb is again going to be a measure of the strength of your base. So just like with your Kb, the larger the Kb, the stronger the base. The lower the Kb, the lower the base. But if you take the negative log of that, then it's the opposite. So then that means that the smaller the pKb, the stronger the base. The larger the pKb, the weaker the base. So that's a good introduction into weak acids, strong bases, and your base ionization constant. In later videos, we'll show how to use the base ionization constant to solve problems, to find pKb, to find pH, to find the Kb value of your substance. I hope you enjoyed this video. If you learned something from this video, please hit that like button right over there, and make sure you subscribe to my channel. Hit that notification bell so you can be notified by other videos I put out. Put a comment down below in the comment section. Let me know what you think and if you have any questions. Thanks for joining me. Have a great day.